Now let us consider the examples given in the exercise 8.3 of your textbook, and all those examples which can be solved by looking back into the examples solved in earlier videos. Those examples will give insight to solve these examples in exercise 8.3. Now let us see exercise 8.3 example. Prove that root 5 is irrational number, and this can be solved on similar lines to the proof of the theorem, that is the root 2 is irrational number. In fact, any square root of prime number is irrational number, which can be proved on par with the example of root 2. And now I will leave it as an exercise. I will consider the second example in the exercise 8.3. Prove that 3 plus 2 root 5 is irrational. The example of the form, as you have remarked in earlier videos, that is a rational number into irrational number is a irrational number. By that remark, we see that 2 root 5 is a rational number, whereas 3 is a rational number. Therefore, rational number plus irrational number is also a rational number. Only thing we have to prove it now. Now, proof of that, the solution of that, the second one I would like to consider example 2, solution to the example 2. If possible, as earlier, assume that assume that that 3 plus 2 root 5 is a rational number. Now all the examples here in exercise 8.3 are to be solved by assuming by using the proof by contradiction. Now we are going to assume that 3 plus root 2 root 5 is a rational number. Therefore, which I can write down 3 plus root 5, 2 root 5 is equal to a by b, where b is not equal to 0. A by b is a rational number because we have assumed that 3 plus 2 root 5 is a rational number, and therefore I can write down this as 2 root 5 is equal to a by b minus 3, which can be written as a minus 3b by b, and therefore root 5 is equal to a minus 3b a minus 3b divided by b into 1 by 2, that is going to be a minus 3b by 2b is equal to, I can write down c by d as a rational number, because we can assume that c is equal to a minus 3b and d is equal to 2b. Therefore, and this implies that root 5 is rational. A contradiction. A contradiction to the fact that root 5 is a irrational number. Therefore, our assumption is wrong. That is, therefore, 3 plus 2 root 5 is irrational. Exercise 8.3 and the problem example 3 prove that the following are irrational. One is 1 by root 2 and second is 7 into root 5. Third is 6 plus root 2. And the examples of the type second and third, we have already solved those and proved that they are irrational number. Yet I will consider first and second one for the solution. Now we can consider the second one, the first one. As usual, we have to prove by contradiction. Assume that one by root 2 is a rational number. Therefore, 1 by root 2 can be written as a by b, because it is there. We have assumed that these are 1 by root 2 is a rational number. Therefore, I can write down root 2 is equal to b by a, that is 1 by a by b, that is a b by a, and which is, that implies root 2 is rational. Here you can have to write down b is not equal to 0, rational number, a contradiction, and therefore 1 by root 2 is irrational. And the second one, again assume that 7 root 5 is rational. This implies 7 into root 5 is equal to a by b, where b is not equal to 0 and a and b are the some integer, positive or negative, whatever it may be. It is anyway a fraction, that is a rational number. And this implies that root 5 equal to a by b into 1 by 7, that is a by 7b, which is rational, because b is an integer, 7b is an integer, a is an integer, integer divided by integer is a rational number. What we have proved now here, root 5 is a rational number, that is root 5 is a rational number. Again, a contradiction. And therefore, contradiction to the fact that root 5 is an irrational number. Therefore, 7 root 5 is irrational.